Let's take a look at a common process that you're going to be doing in the lab in chemistry. So something that we're always working with are dilutions. So you might have a solution with a certain concentration. This is a colored solution. And a lot of times solutions aren't the right concentration. We might need to weaken them in order to work with them. So we go through this process called dilution, whereby we add more solvent to the solution. So if you take a cup of this and you add more water, it's becoming less concentrated. It's becoming lighter in color as well. And this is what we call dilution, the process of a concentration of a solution being lowered by addition of solvent. Now don't forget our definitions of solvent, solute, and solution that we went over in the previous video. The definition of a solution is a homogeneous mixture of two or more substances. So this is the solution. The solvent was the water that was added. The solute was the agent that's in here, the solid agent in here, that's giving it color. And so together, the solute and the solvent make the solution. So we're going to use a formula in order to calculate concentrations of diluted solutions. We had learned the unit of concentration in the last video, the moles over liters. We're going to use this concentration in order to set up a relationship so that we can solve for how to accurately make solutions. When we're talking about dilutions, the original solution that was here before I added more water is what we consider the stock. It's the more concentrated solution. So concentrated. And the diluted solution is the new resulting thing that we're going to look at. Something we can say about the solution before and after it was diluted is that inside of this quantity of solvent, there are still the same number of moles of chemical. So I colored this water with turmeric, and I had to put in some turmeric. And that amount of turmeric that I put in here did not change after I put the water in, right? So we can assume that I put in a certain number of moles of that substance, which means that the moles of a substance in the stock are the same as the moles of a substance in the diluted solution. By knowing this relationship, it can help us calculate concentration of the solutions that we've made. So if you've had chemistry before, you might be familiar with this formula that I'm going to give you. It goes by C1, V1, C2, V2, or you might have heard M1, V1 equals M2, V2. These stand for concentration or molarity. So concentration, or we can call it molarity, which is why sometimes it's M1, V1 equals M2, V2. V stands for volume, volume. So we've got concentration, times volume is equal to our new concentration times our new volume. And this belongs to our stock, and this belongs to our new solution, The reason we can set these equal to each other is because we know that the moles inside of the solution has not changed upon the dilution process. We can also see this reflected in our units. We have moles over liters times volume, which is often in liters, which will give us moles. So if we perform that on one side of the equation, we're going to end up with moles equals moles. So let's assume that the concentration of the initial stock that was done here before I added water was 1 molar. Let me change my pen colors. So let's say it was 1 molar. This belongs to our stock. The C1 and the V1 belong to the stock. The volume was 1 cup. So 1 cup. The new concentration of our solution, we do not know. The new volume, however, I added another cup of water, is at 2 cups. Okay. So we can use our C1, V1, C2, V2 in order to solve for the new concentration. So if we have 1 molar, and we had 1 here, and we want to find this one, we had 2 here, this is our X. We can solve for X by dividing both sides by 2. And we've effectively cut the concentration in half. So our new concentration is 0.5 molar. Which makes sense, right? We put in double the water, so therefore the concentration should be half as concentrated. Let's take a look at this in a more accurate light in a situation that's closer to a laboratory setting as opposed to cups. Let's look at liters. So say you have a 2 molar solution and you want it to be 100 mils of a 1 molar solution. And we want to find out how we want to make that, right? So a lot of times when I'm in the lab working, I've got a certain concentration, I need to make something for the students to use, and I have to know this is how much I need, and I got to go make that. So the question is, how do we make this? We can use C1V1 equals C2V2 to figure this out. The stock is always the more concentrated. So remember that our concentrated one is always the stock. So you may want to write that down because you'll need to know that. So if you've got a 2 molar solution or a 1 molar solution, the one that's more concentrated is the stock. So in this case, this is the stock. So this is going to be our C1 for concentration. This is C2 for concentration 2. We want to make 100 milliliters of our new solution. So that 100 milliliters belongs to the new solution, which means it's volume 2 because it belongs to the solution, which leaves us with 2 molar. And on this side, we filled in 1 molar, and we know that we have 100 milliliters. Okay. So it looks like we're solving for the volume here. It looks like we're solving for V1. That's the thing that we don't know is V1. So in order to solve this problem, we can simply divide both sides by 2, and our V1 is going to be equal to 50 milliliters, half of 100. And this is the amount of the 2 molar stock that we use. So 50 mils of stock. So if I wanted to make the solution, what I do is I'd put 50 milliliters of stock. I'd measure that out. And then I'd fill it up to 100 milliliters with water. Because this is our solution, which is defined as the water, so our solvent plus solute, and then this is our stock over here, which is our stock solution. Now something you might notice here is that our units were left in milliliters. You might be used to seeing these problems where you're required to use liters for volume on both sides because liters will cancel liters in a unit conversion fashion, right? However, with these problems, because we're setting them equal to each other, the unit on the volume actually does not matter. Because we're setting this up as one side of the equation is equal to the other side, as long as both sides have the same units, you're okay. So if this is milliliters as opposed to liters, that is fine in this situation, because when you go to solve, right, you would say we wanted to solve for concentration. We divide both sides by milliliters, right? And then this goes away. So as long as you remember that whatever volume is currently used, whatever's plugged into the equation unit-wise is the unit that your answer is going to have, you don't actually have to convert to liters for this particular equation. All right, so let's try this example now. How would you make 10 mils of a 0.2 molar solution from a stock solution of 0.5 molar? So use your C1V1 equals C2V2 equation. Make sure you properly identify the concentration and volume belonging to the stock and the concentration and the volume belonging to the solution, and plug those into the right variables in the equation, okay? So there will be a quiz question that pops up into this on which numbers should go in for which variables in the equation. Currently, it's asking us to make 10 milliliters of a 0.2 molar solution from a stock solution. So the stock is 0.5. So that tells us that this is 0.5 molar here. And our solution is 0.2 molar and 10 milliliters. So the question is, how would you make it? First things first, we do need to solve this. So go ahead and solve for V1. So if you put this in and you divide both sides by 0.5, because we're solving for V1, or I've labeled it X. Okay, this goes away, and we find that this is equal to 4 milliliters. 4 milliliters of what? What is this? The 4 milliliters belongs to our stock. So remember that this side of the equation is the stock. This side is the solution. So nowhere in this problem are you solving for the volume of water. We're only looking at solutions, the more concentrated stock and the diluted solution. So what you would want to do is you'd pour, if you had a graduated cylinder, that was 10 milliliters. You'd fill it to 4 with the stock solution. And then you'd fill it to 10 with the water. So that's 6 milliliters of water. Let's do one more practice problem. Okay, so for this one, the solution used in hospitals is an IV, saline solution, and they want a specific concentration at 0.155 molar NaCl. It's typically prepared by diluting a stock solution, the concentration of which is 1.76 molar with water. What volume of stock solution is required to prepare 2 liters of the saline? So see if you can do this one on your own without my help. Let's take a look at how to solve this. So our stock solution, our more concentrated, right, the one with a higher molarity value, is 1.76 molar. So if you don't see the word stock, it's still the one with the higher concentration. We're given another concentration value. We've got 2 molarity values, right? So our C2 is the one that's less concentrated, 0.155 molar. They give us a volume. Let's see, does that belong to the stock or the solution? What volume of stock? Okay, yes. So that goes, oh wait, what volume of stock solution? We're solving for that. Okay, I almost missed that. Is required to prepare 2 liters of the saline. So we want to make 2 liters here. So if you want to solve for V1, we need to get it by itself on both sides. We're going to divide both sides by 1.76. And you should end up with your volume is 0.176. And that is volume of the stock. Make sure we add our unit on this. Liters. The unit's liters, because the unit here is liters. If the question asked for milliliters, you would need to convert this. A lot of times in the lab, we're measuring milliliters. Like I don't have a graduated cylinder that measures 0.176 liters. I do have a graduated cylinder that measures in milliliters. So what you'll probably need to do in a realistic situation is go to milliliters from here. So you'll need to remember that this is a difference of 1,000. So if you did 0.176 liters, you want to get to milliliters. There are 1,000 milliliters inside every 1 liter. So you need to multiply this by 1,000, which would give you 176 milliliters. And so that's what you'd end up measuring out in the lab. And then filling that to the 2-liter mark with water. So it would look like this, 176 of the stock. And then you'd fill that up to 2 liters or 2,000 milliliters with water. So this would be water, so that your new solution has the stock plus the water to give you a diluted solution that is less concentrated.